Hi, my name is Joseph Harden. I'm in the distance section of Buckner's 535 class. And for my demonstration project, I'm going to do something you've seen probably every day. And it's called an induction loop sensor. And where you've seen these is at traffic lights. So at a traffic light, they have these cuts in the road. And they kind of look like that. And what these are cuts for housing a giant coil that is used to determine when your car is there. Okay? So an induction loop sensor works by measuring the inductance at different times. And when your car is over top of this loop, the axles and the engine and all these metal parts will disrupt the magnetic field produced by this inductor. Okay? So we know inductors produce magnetic fields, and when it's disrupted or altered, the inductance is going to change. Okay? So your car will change it by producing eddy currents and by having a different permittivity than the air around it. Okay, so how do we measure the inductance? We measure the inductance using an LC circuit. From Kirchhoff's voltage law, we know we can derive it and find that this circuit has a natural frequency or a resonance. Okay? And this resonance, or this frequency, can be calculated using this equation. We're going to use this equation to determine the inductance of the coil underneath the road. So for my demonstration, I'm going to be demonstrating how this typically works. Okay? Now normally they have an input from the coil, and this will come to a microcontroller. And when the inductance changes, it'll send it out to the light. So that's essentially what I'm going to be doing. Except this is going to be an Arduino, and this is just going to be some LEDs that I have set up. Okay? Now, the Arduino is too slow at reading analog signals, so I have to convert the analog signal from the coil to digital before I can measure it with the Arduino. Okay? So essentially what I'm going to be doing is you'll have a voltage signal, and this will be going very fast. Okay? I mean this step will be, maybe several microseconds. Okay? And what I'm going to do is convert this to a square digital wave. And that's how the Arduino is going to read how fast this frequency is. Okay? So it's actually going to measure the period. So it'll measure how long this length is, convert the period, which T is 1 over F, to frequency, and then we'll use that first equation I showed you. This is my circuit that I created to demonstrate the induction loop sensor. So this is your coil, and this is your capacitor. So that's what makes up the LC circuit. This is your analog to digital comparator, and of course this is your Arduino right here. So let's say theoretically you're sitting at this red light right here and you're waiting for it to go green. So you pull up on top of the coil and the light changes. So essentially we took the induction, saw the change, and compared it to the average, and as long as it was large enough we knew that it was a car, or in this case a pair of pliers. Thanks guys.